Hello friends, this is Elder. A lovely morning to you guys, and in this video we're going to be talking about differentiation. Now, the major doctrine about differentiation now would be in the form of this: if and when you are given y equal to an equation now such as ax raised to power n, what you're going to have there would be, if you are told to differentiate this now, it's going to be in the form dy over dx. That is the basic way differentiation is illustrated, right? That's how you represent differentiation, dy over dx, and that will be equal to, now how do we differentiate this equation given to us here? So as a general rule now, we are told that if we want to differentiate, the general formula would be to use this power over here to multiply this coefficient over here. So it's going to be n times a, right? Then we have x. We are going to rewrite that x we had there, this x, we are rewriting it. Then you are going to subtract 1 from this n here, subtract 1 from it, so you're going to have n minus 1. This is what we have in this context. So let's look at some actual examples and see how this plays out. Now, I know a lot of you already have a good background on differentiation and integration and whatnot. So if you already know these things, right, what I will encourage you to do, when I write the question on the board, right, on the black screen now, you pause the video, solve the question, and put the answers in the comment section. I don't know if you're getting me. Solve the question and put the answers in the comment section. Then play the video to check if what you've done is correct. So we're going to have, as our first example, y equal to x raised to power 8. X raised to power 8. So to differentiate this now, we're going to have dy over dx will be equals to, so we said that we're going to use this power here to multiply whatever coefficient we have in front, and in this case now the coefficient is an imaginary one, right? We're going to have 8 times 1 x raised to power 8. So according to the formula now, we'll subtract here's the formula. We're going to subtract 1 from this power, so it's going to be 8 minus 1. So in the aftermath, we're going to have 8 times 1 gives us 8, x raised to power 7. This would be your answer. How true? Very true. So if you already got it, please signify in the comment section. Next, let's look at another example. Let me take this off the screen. Okay, so we have y equal to 3x raised to power 4. So how do we work with this now? So we use this power here to multiply the coefficient in front. So we're going to have y equals to 4 times 3, right? X raised to power 4. You subtract 1 from the power according to what our formula tells us, 4 minus 1. 4 minus 1, and you always subtract 1 from the power. So 4 minus 1. Okay, so we're going to have 1. So this gives us 4 times 3 gives us 12. Then we're going to have x raised to power 4 minus 1 would give us 3. Very true. That will be your final form, right? Let's look at more complex forms of this. So I'll be taking everything on the screen now. Now, suppose we are told to differentiate something in this form, right? So we're going to handle each of these parts as a unit of its own. So what you're going to have here will be dy over dx equal to, now 2 times 3 would give us 6 now. So you can go ahead and write that if you want to write it out. Let's write it out for this very first time. So 2 times 3, you have x now. Obviously now you should know that we're going to subtract 1 from the power here, so minus 1 plus 2 times 5, 2 being the power here, going to subtract 1 from here. Minus 1 minus 2x, right? Notice now that I didn't write anything, so let me just illustrate that more openly so I can see it. So notice now that the power here is 1, right? So that was why I chose not to write anything, but let me write it out since this is the first time we are working with such variables. So that we're going to have 1 times 2, 1 times 2, we're going to have x raised to power 1 minus 1, right? X to power 1 minus 1. Let's work that out. Let's see how it goes. So 2 times 3 gives us 6. We have x. Here we're going to have 2 raised 2 minus 1 now will give us 1, there being the power, plus now 2 times 5 gives us 10, right? We have x. 2 minus 1 here gives us the power of 1. On this other side now, 2 times 1 would give us 2, x raised to power 0, right? So let's finish this up. So 6x raised to power 1 still gives us 6x plus 10x raised to power 1 giving us 10x minus, now listen, for me this is, now you recall that anything raised to power 0 gives us 1, right? So but that would not mean that everything on this place will be 1. That wouldn't, if you do that, that would be something, but that would not be mathematics, right? Yeah. So what is going to happen now is that this power of 0 affects only the x, so you're going to have 2. This x becomes 1, so you leave it in this form. That will be your final form. Let's look at some more complex forms of this. Now here's a very interesting one now, and I would love you to pay very close attention, because if you don't pay attention you might miss it. Now, so to solve this question now, we're going to have, let me use a different color of ink. Yes, so we're going to have 4, yes, I like this, over 3, right? So if I should take this x raised to power 2, right, if I should take it and apply the law of indices to it, I can simply move it up now and give it a sign of minus 2, because according to the law of indices, when we have a denominator like this, right, we can simply move the denominator upwards and the sign becomes a negative of the original power, right? So plus 5x. Now let's differentiate. So dy over dx now will be equals to, we're going to use this negative power to multiply 4 over 3. So we have minus 2 times 4 over 3x, right? The power is, we recall now that we're supposed to still subtract the 1 from the power, despite the fact that it's negative. So we're going to have minus 2 minus 1, right? So plus 5. I can choose to just write 5 there, but let me illustrate how that happens. So notice now that there's an imaginary power of 1 here, right? So 1 times 5, that's what we're going to have there. This is trying to break it down to the simplest form, right? So we subtract 1 from the power, so 1 minus 1. So minus 2 times 4 will give me minus 8 over 3. And we have x now. Minus 2 minus 1 gives me minus 3, plus 1 times 5 gives me 5 x. Now if it's 1 minus 1 gives me 0. Let's move the screen downward a bit. Now to solve this now, to finish this up now, we have minus 8 over 3. Notice now that if I choose to reverse the law of indices that we applied in the first instance there now, I can simply take this x to the power minus 3 down to the denominator and it eliminates the minus sign. That was indices which we were taught in first semester. So we are going to have 8 over 3x raised to power 3. So bringing it down the denominator, the negative sign disappears. So 8 over 3, that's negative 8 over 3 x raised to power 3 plus, now anything raised to power 0 is 1, so this gives me 5. So this, my friends, would be your final answer. So I'm going to leave one for you to solve. I'm going to give you the question to solve. Leave your answers in the comment section, right? Leave your answers in the comment section. There you have it, friends. This is your very first question, right? Solve it and leave your answer in the comment section. Here goes another. This is another very interesting one you can work with. Thank you so much. See you in the next video. Now don't forget to hit the subscribe button, right, so that you can get more of our videos. We're going to be releasing videos on all courses this semester.